So welcome everyone to the Youth Services Interest Group SciStarter workshop. This workshop will be recorded and the link will be sent out with the March newsletter. I just have two quick updates before we get started. Our next meeting will be a summer reading idea share. It'll be on Wednesday, April 30th, in person at Wayne Public Library and virtual, and will be in collaboration with the Teen Interest Group. And then also, I'm excited to announce our May workshop will be presented by the Eric Carle Museum of Picture Book Art. And thanks to everyone who voted on the topic of the workshop, the winning topic was Little Books, Big Feelings, Picture Books, and Social Emotional Learning. And the virtual workshop will take place on Wednesday, May 14th from 1 to 2:30. And you can keep an eye out for our March newsletter for more details about these upcoming events. Now let's get started with today's workshop. Our presenter today is Heather Manley Caldwell. She is the STEM coordinator at Ringwood Public Library and a SciStarter ambassador. We thank Heather for taking time out of her day today to present for us on this important topic. And take it away, Heather.
Hi, I am from Ringwood Library, and today I'm going to be presenting on citizen science for libraries, how we can expand STEM to include citizen science. So at this time, before I really get into more of an introduction about myself, in the chat, if you could put in if you have ever participated in a citizen science project, and if you have, say what it was. All right, so while you work on that, if you haven't done any citizen science, go ahead and put that in there. If you have no idea what citizen science even is, go ahead and put that in the chat as well. All right. Like Melissa said, I work at Ringwood Library. I'm in tech services at Ringwood Library, but I'm also a STEM coordinator there. In my previous lives, I have worked as a technical writer and as a biology teacher. So I have a STEM background. And so that's kind of where my interests come from. On this slide, you can see my email. You can always email me directly with any questions. Also, there's a link here for my profile on the SciStarter website. If you ever want to contact me as a SciStarter ambassador, you can use that link, and I'll put that into the chat. Okay. All right. All right, so moving on into what is citizen science. Citizen science is basically research which non-professional volunteers contribute to. Volunteers can either collect data, make observations, or even analyze data. Sometimes they're even used as the subjects in a study. Citizen science is crowdsourced, which means it takes advantage of large numbers of people, and that's necessary because maybe the research is asking questions that can't be answered with a few people. They need lots of people to help do the research, or again, to be the subject matter of the research project. You may have heard citizen science called by other terms, participatory science, community research, or some of the other terms that you may have heard. Let's see. All right. Citizen science, from my perspective, with a science background and a teaching background, I believe citizen science is important because it helps promote data literacy, information literacy. It can bring patrons some knowledge about the scientific process. So it's good for people learning about science, but it is also good for scientists who need the benefit of extra hands on deck, basically. I'm going to take a little break. I keep talking about citizen science, but there are a lot of projects that are research oriented that are not necessarily science. So if you're not huge into science, but you like history, you can find a research project based in history. I know that there are projects that do a lot of transcribing from old documents, and they just need more people to help do that. So there are other crowdsourced research projects that you could get involved in. All right, let's talk about the type of skills someone would need to do citizen science. These are basically the skills that one would learn or use in a research project. You ask questions, you make observations, you collect data. So these are the skills that someone who is involved in citizen science will practice. And I think it's good for our patrons, for especially younger patrons, to kind of learn by doing. That's basically what citizen science is. So they're actually doing the research. Okay. So here is one example of a citizen science project that is accomplished because there are so many more people doing it than the actual scientists. Stall catchers is what it's called, and I'm gonna put that in the chat as well, that you can go take a look at that project. This project is basically the person is looking at brain tissue from mice, and you can see the blood vessels moving through the pictures, and they have to identify if there looks like there's a clog in a blood vessel. This helps scientists identify if there are blood clogs in the brain of these mice, and that helps, that simulates Alzheimer's disease. And that's part of what Alzheimer's is the blood flow isn't up to par. So this helps researchers identify which of their subjects have the simulated Alzheimer's, and that helps them do their research. So we can see the statistic on the screen that citizen scientists did this project over one weekend. It's still a continuing project, but they recorded that citizen scientists did over 2,500 hours of research in one weekend, and that would be the equivalent of 3.5 months of research time, let's say by a couple of grad students in the lab. So you can see how this could speed up the research project. So that's a good one for patrons or anyone who's interested in health issues. Let's look at some other projects, results of projects. Because of citizen scientists, we now know that birds are breeding earlier and flowering plants are blooming earlier. So basically, nature lovers who observe the world around them can add their data to these databases, and scientists are finding these trends, and they can add to their growing evidence of climate change. Another example is that they have found that there are 50 types of bacteria living in one's belly button. Now, I really don't know the usefulness of that information, but it demonstrates that citizen science is needed to get more subjects. So they basically sent out kits for people to swab their belly buttons and send that back to them, and then they can analyze what kind of bacteria are in their belly buttons. So they could get lots of people to participate, and they could get people from around the world, not just from where they are locally. They could get people participating from the other side of the planet. And in that way, they can analyze the bacteria, see if there are differences in the bacteria from, in different places around the world. Another result of citizen science is that we know that there's a new type of aurora in the night sky. And the citizen scientists who participated in the project actually got to name it, and they named it Steve. So that demonstrates one of the perks of being a part of citizen science. Sometimes the participants will get to, if they find a new species or rediscover a species, they can help name it. They can get their names on actual scientific papers. So there are perks to being part of citizen science. All right, so who can do citizen science? The short answer is anyone. I got involved about 30 years ago. I started with Project Feeder Watch, which I'll send the link to that in the chat. This is a really easy one to get involved in. Basically, I watched my bird feeder over the winter and recorded the types of birds that came to the feeder. eBird is a very similar one. They're both run by the Cornell Lab of Ornithology, and they're both very easy to get involved in. So that's how I started. And then I brought the project to the classroom when I was teaching biology. So the upper picture, you can see a bunch of high school students watching birds or pretending to watch birds. So I got them involved in the project. I told them how to do it. Basically, we had to start from the ground up and, this is how you use binoculars and this is how you identify a bird. But then we got into like what it means to actually count the birds. Why would we do that? And so on. Another project that I was involved in early on was Earthwatch. Earthwatch expeditions are basically trips that you take and participate in science in projects around the world. This particular one was in Spain. So in the picture we have the gentleman with the beard was the primary investigator. He was a professor from England. Over on the left, we have a professor from Spain. And then the two young women in the middle, they were graduate students. So they were the actual scientists on the project. And then the rest of us in the picture, we were all citizen scientists. Basically, we went for 2 weeks. They taught us exactly what we needed to do. And then we were able to help with the project. Let me put this link in the chat too. The project that we did while we were in Spain, we were counting butterflies, basically coming up with a population count. So there I am. They taught us how to catch the butterflies and how to mark them and how to release them. I was able to bring that information back to the classroom as well. But I'm going to get into how you can bring these projects to the library. Basically, if you do any kind of STEM programming now, you should be able to add citizen science pretty easily. This information, this is a sheet, a graphic that I got from the SciStarter resources. So I'm going to add that to the chat. So if you have, let's say you have gardening programs at your library, you can easily add in something like the Great Sunflower Project. If you have a club that likes to do bird watching, or you have an astronomy club, you could go to one of their meetings and show them how to use one of the projects like eBird or Project Feeder Watch. There's a lot of astronomy ones as well. There's an exoplanet project. So you could do something like that where you just kind of add it into a program that you already have. So that's an easy way to add citizen science to the library. Let's see. I'll tell you a little bit about a program that I started, how I incorporated citizen science. Last year, I created a program called Data Detectives. I was working with kids mostly in grades 4 through 8. I went into the schools at the 4th and 5th grade level, and then I had a couple of groups here at the library. One of them was a group of just girls, grades 4 through 8, and then I had a group of homeschoolers. Basically, I taught them how to use the Globe Observer app. So we collected a lot of data for that project, which included air temperature, surface temperature, wind, humidity, basically weather data. And the group at the school, they actually did a project where they compared surface temperature to air temperature and they were looking at the blacktop at their playground versus the grass at their playground. And if you can see in the graph in the middle here, this bar graph, the two smaller bars represent air temperature and temperature of the grassy area, and then the blacktop area is the higher one. So what they found basically indicated that blacktop is hotter than grass. And we talked about what that meant for the heat island effect, and what that might mean for where they might want to actually play during recess. So they took all these skills that they learned and brought it to the library during the April eclipse. All of my data detectives during that day collected weather data. They posted it for all the patrons who were coming to actually watch the eclipse. And we also entered the data in the Globe Eclipse app. And the data on the left here in this graph is what they collected that was entered into the database that NASA scientists can use in their research. And you can clearly see that the temperature dipped throughout the day. We observed, about 2.5 hours around the eclipse. So that was kind of really cool for them to see the data afterwards as well. All right, so let's talk about how I get started with projects like this. I usually start with talking about how we collect data. There's two types of data, qualitative and quantitative. Qualitative is descriptive, using your 5 senses. So we'll usually sit outside and I'll say, just write down anything that you notice using your 5 senses. Quantitative is measurements. So they like to do that kind of thing. If we have instruments, taking temperature and stuff like that, that will be actual numbers, counting, and so forth. So what I want you all to do is to use your 5 senses. Imagine that this cherry tree is right outside your library. I want you to use your 5 senses and tell me what you notice about the cherry tree. You can go ahead and maybe put some things in the chat. What do you notice? Obviously, you're going to use your sight more than your other senses, but you can imagine that you're standing there too. What might you feel? What might you hear? Those are the kinds of things that I would tell students to listen for. All right, I got warmth, right? It'd be spring when the flowers are blooming, fully bloomed flowers. Yep, that's what we see in the picture. Rustling of the petals in the breeze. The blooms are light pink with a dark pink center. Good. Oh, a scent. Maybe you would notice a scent. Good. So those are the kinds of things that I would get the kids started with thinking about. We could get more specific with how many leaves do you see in relationship to the flowers? You see a lot of leaves there. And then do you see any buds on the branches? And are the flowers in full bloom? So that would be a simple step-by-step through a project, and there is an actual project for this, and it's called Bud Burst. So basically the process you just went through with me is what you would do for this project. So that's also a nice, easy starter project. So if we had included our results in, entered them into a database, we would have just participated in actual citizen science project. Now you may be wondering if the results are trustworthy. If I have a bunch of 4th graders taking observations, are we going to really trust it? And the answer is yes, we can, because these projects have a lot of controls on them. They have very explicit instructions and procedures that you have to follow. They do provide training and assessment. In a lot of cases, it's not like you're going to class and getting tested. It's gamified. A lot of these programs are made to be fun, so that's easy. Experts do review all the data. There's replication of data. That means because they are asking so many people to give them data, if your one piece of data is a little wonky, the outliers really don't count. You know, if you have millions of pieces of data versus 10 pieces of data, it kind of washes out if you have something that's not in there that's right. And there's redundancy. Sometimes they will ask you to enter your data online, but then also send something in. Some projects will do that. So you don't have to feel like you're doing a project that you might ruin someone's research, because you really won't. All right, now bringing citizen science to the library, you can do as much or as little as you want. You can just create displays about citizen science. You can do programs. You can run classes like I did, or you can just have a subject matter expert come in and do a lecture. For some libraries, your patrons may rely on you for Wi-Fi, or they might want to borrow a device or use your computers to enter the data online. So those are ways we can support patrons doing citizen science. And of course, providing field guides. You know, if they're watching birds, they might want a field guide on identifying birds. You can also create kits to lend. For instance, at Ringwood, we have a few kits. The Birder's Backpack has a pair of binoculars and a field guide in it. The Measuring Light in the Night is also a backpack. It has a planisphere in it, like a star chart. It also has this little device. I don't know if you can see it. That measures the night sky and the light in it. And so that project, Measuring Light in the Night, or Globe at Night, is all about light pollution at night. You can create a kit for moth observations, and it's really easy. Get like a white sheet, some UV lights that track the moths, and then the users can track that data in iNaturalist, which is another project that I'll get into. We also have the Test the Waters Family Exploration Kit, which I'm going to talk a little bit more in a little bit. As far as books on citizen science itself, there aren't that many. This is one of them, the Field Guide to Citizen Science, that we have here at Ringwood Library. So you can suggest that to patrons to check out, or if you would like to read it yourself, I'm going to send you the link to where it is in the catalog. And it does a good description of a bunch of different types of projects that you can get involved in. All right. So I'm going to show you some more resources. You know, if you really just don't want to jump in and do a project yourself, but you wouldn't mind making a display or putting out some flyers, maybe put up a poster, SciStarter has a lot of resources for that. You can print posters, flyers, bingo sheets. I'll put that in the chat as well. If you have a button maker, they have some nice buttons that I've made. They also have this huge guide that you can print out if someone wants to read that. And they have webinars that you can take. So there's a lot of stuff there that you can access. Put that in there as well. All right. Some other resources. The National Library of Medicine also has a good site for starting citizen science programs. So I'll put that in the chat when that comes up. Put the circle of death here. Okay. And SciStarter has kit building resources as well. So those kits I talked about before, you can go to that site and it will tell you exactly what you need to buy. It has printouts that you can print and laminate and include in the kits. Let's see, let me get this up. I'm getting the circle of death. I might have to send the links to you later. Okay. So this is one of the kits that I have. It's called Test the Waters. It's full of activities that families can do at home or you can do in a small program at the library. It's all about the importance of water for your body and importance of water to the environment. It's actually kind of cute. I did it with kids. It has this apron that you can put on and you identify where all the organs are, and then you talk about why you need water for your organs. There's also some materials in there for you to participate in the Crowd the Tap project. So basically you can test your tap water and then you can test the pipes for lead. So maybe in areas where you have older infrastructure, that would be interesting to your patrons to see if they have lead in their pipes. And I don't know that the National Library of Medicine is still giving these away, but for some reason they gave me 2. So I have an extra one and I'm going to raffle that off. So if you want to be part of that raffle, you can email me at caldwell@ringwoodlibrary.org. Just put in the subject that you would like the kit, and I will do that. The Crowd the Tap site, let me put that in the chat for you. And we could talk about some upcoming opportunities for you at your libraries. April is Citizen Science Month. So you could do something as simple as a display or, just put out some flyers or do a bingo sheet with your patrons or your young patrons. April is also Million Acts of Science Month. Basically, they want to get organizations doing some kind of science project and they want to reach 1 million. So you can be a part of that. You do any kind of programming with citizen science. You can put your library's name in the calendar on their event schedule, and you can become part of that 1 million acts of science. The next opportunity that's a good one is a Global Big Day for migration, bird migration. So if you have a lot of people who are into birding, that might be a good one. In New Jersey, we have the World Series of Birding, which is basically a big competition. People make teams. They go throughout the state looking for birds all in one day. So you could have a program talking about that. You can show people how to use Project Feeder Watch or eBird as part of that program as well. So those are 2 upcoming opportunities where you could involve patrons in some citizen science. Let's see. All right. How do you get started with citizen science? Basically, you want to find something that you're interested in or your patrons are interested in. But all of these sites that I have listed here that I'll give you the links to have great resources. They're all hubs for projects. So a lot of projects are listed and you can kind of go through and look and see what you might be interested in. There are ways to filter on them and they're organized so that you can find what you're really interested in. I like Zooniverse is good because it's not just science. I found a few like history things there. You can look at historical weather data. You look at old ship logs and help them find historical weather patterns. So that one's kind of interesting. The sitsci.org, I think, is more like environmental projects. And the NASA one, well, it's NASA, so that's kind of cool. You actually contribute research to NASA scientists. And if you ever wanted to do a NASA project, you could get a solar system ambassador to help you with it. They are similar to SciStarter ambassadors, where they do free programming. And if you need a name, we use one in Ringwood a lot. So the solar system ambassador is a good resource. Okay. Like I said, you might want to find a project that really interests you. If you're passionate about something and you create a program around it, you're going to, obviously, that passion will show through and your patrons it will be infectious. But if you know that you have a group at the library that has a particular interest, you can look for projects based on those interests. A good one for a lot of libraries, I think it's kind of trendy now that we have gardens near the libraries. If you have a garden, you can go out with your patrons and just count the pollinators that are there. You know, if you see butterflies and bees, you can go out and take some time and contribute to a project like the Great Sunflower Project. If you've got little ones who are really interested in butterflies, you can do a caterpillar count when it's time for them to come out. I mentioned the Globe at Night project for light pollution in the night sky. You can create a kit for that. Let's see what else we got. There's some health and wellness projects that might not be that appealing to kids, but maybe some older patrons. But these are actually kind of cool. Actually, they're very, very cool to look at. Eureka is all app-based. It's basically playing games. You answer a few questions about your mental health, but then you play games. And that's how they collect their data. So I'll send the links for these in there. iWire is also gamified. Basically, you map out the neurons in mouse and zebra retinas. Basically, you get a little cube that is 3D, and you have to basically follow the neuron where it goes. And if you go to the website, you can see a huge map of what they are creating. And then All of Us is basically a project where you can share your health information. So that one is probably not as fun for young kids. This is which one? Okay. All right. I know I'm throwing a lot of links in the chat, but I will make this presentation available later too. All right, some nature-based projects that are very easy to get started with. I mentioned eBird before. iNaturalist is another easy one. Basically, you go outside and take pictures of whatever you're seeing, whether it's plants and animals, and then you upload it to the database. Both of these have companion apps that help you identify what you're seeing. So those are really great tools to teach kids. They love to use Merlin Bird ID. Basically, it listens for birds and identifies what it's hearing. And then once it identifies what it's hearing, you can enter that into eBird. Same with iNaturalist. The Seek app will identify something for you. So you take a picture of a leaf, and it'll tell you what kind of plant it's from, and then you can record that in iNaturalist. iNaturalist is a great, like I said, starter project. Basically, just go out, take a picture, and submit it. But on the back end, you can enter the database and look to see what everybody has put in there. So we've gone on a couple of hikes around the library and collected data, and then gone inside and looked to see like what kind of species we have. And it's interesting. We've recorded maybe 51 different species, and it will tell you if the species is native or if it's invasive. So out of those 51 species that we've recorded, we found that 9 were invasive. So we thought that was pretty high. So you can kind of go full cycle through these projects. You can show them how to collect the data and then go look at the data and start to come up with some ideas about the data. Why would we see so many invasive species around the library? You can start asking those questions. Some other related websites that might be supportive, especially if you feel like you could do the bird projects. Birdcast tells you when you should expect a big migration in your area. I think you can get email notifications. They might think that you'll see a big flyover in the next couple days. You'll get those emails. Bird Migration Explorer is kind of fun to add to any program if you're talking about birds. It shows all the flyways around the world. So you can trace where birds in your area are, where they come from or where they go to during migration. And then GBIF is a big database where a lot of these projects contribute to. This is where scientists then can go find the data, create data sets, and start analyzing them. But what's nice about it is that it is open sourced and anyone can go in and look at the data. So again, if you're doing a project, you might want to come here and if you're looking specifically at certain kind of birds at your library, you could go in here and get some information about them. Let's see. I've created a Padlet that has a lot of information about citizen science that you can use, or you can pass on to your patrons. So you can scan that if you want. There's also on SciStarter, there's some training modules that help you understand what citizen science is and how you can incorporate it in any programming. I'll put that in the chat. Your library can become part of the network on SciStarter. So if you do any programs, you can get on their calendar. They'll send you any webinar opportunities. I think I put the Million Acts of Science already in the chat. And then the SciStarter Ambassador Program, you can either train to do that yourself if you want, or what I would suggest is if you have volunteers at your library that are really into science, you could suggest it to them. And then then you can get nice free programming from them. All right, so that was my presentation. I'm going to put in the chat my email again. If you have any questions, you can always ask me. And since I am a SciStarter ambassador, I can also offer that if you wanted to try something, try a program, I can definitely come on board and help you, help facilitate that. So any questions?
I have a question. What's the youngest age you've ever done one of these programs for?
So the homeschool group that I had a range of kids, and I would say probably the youngest there was 6 or 7. I tend to work more with like the tween ages, like the 4th and 5th graders, but I can see doing some of the projects with little ones. Like I said, the pollinator count I think would be good, and the caterpillar one. And honestly, recording temperatures is really easy. You just show them how to push the button and read the temperature. So the Globe Observer app that I did with the data detectives, a lot of the younger kids could do it. A lot of these projects, like anything online, you have to look at the age. Sometimes that you have to be 13, sometimes you have to be 18. The project with NIH, sharing your health data, you have to be at least 18, I believe. So you do have to watch that. So a lot of times I just work around that by, we have an account for the library for iNaturalist, and we just use that. I don't make everybody create accounts, and that becomes time consuming to ask people to come prepared with their own devices and everything. So
I feel like these programs would really expand young people's idea of like what it means to be a scientist, because maybe they still have like a rigid view of like, oh, a scientist works in a lab in a white coat, and it's like, no, you can go out there and you can do science, which is, I really love that.
yeah. Yeah, it does provide a lot of opportunities. When I go to the schools, I'm doing data detectives again at the school, and they just love being able to get outside. I have what's called a sun spotter, so we look at the sun, the surface of the sun, and they count the number of sunspots. It's just a lot of different tools that maybe they would never have been exposed to in a regular science class. Any other questions for me? Put them in the chat. I'm going to share the iNaturalist website. Actually, let me show you Zooniverse. So Zooniverse is one of those hubs where you can find different projects, and I like the way this one is laid out. Let's see. Because it's kind of by topics, and it's not just all science oriented. Like you can see here, it says arts, biology, climate, history, languages, literature, medicine, nature, physics, social science. So there's a wide range of topics that you can look at. And so that, I think it starts with you. You want to do what you're interested in, because like I said, that passion then will kind of flow over. But again, if you do have a group that's, they're really into astronomy, there are projects that you can focus on that way. Have iNaturalist, and this is the GBIF open access database. So you can actually come here and take a look at some of the data sets that have been created by citizen scientists. And you can see that a lot of papers have been written based on this data. So I think that's important for kids to see too, that what they do could make a difference. Something I also forgot to mention is that these research projects are usually started by the researcher, but sometimes it's the opposite. It's a community that is looking to explore an issue, a local issue, that they start a project, then they get some scientists on board to help them. So for example, you may have a community that's wondering about the quality of their local water, or they want to do some kind of cleanup. So community members can also start these projects. So if you have patrons who are community minded and want to really explore something, that's an option too. Any other questions? Anything in the chat?
Well, thank you very much, Heather. This is really interesting. And we really appreciate you taking out your time to present this for us. And we'll make sure to get the recording out to everybody. And then we hope to see everybody again in April. And that date again was April 30th for our summer reading idea share in collaboration with the Teen Services Group. All right, so thanks everybody for coming today. Thanks again, Heather, and have a good day, everybody.
Thank you.